Sure. So is my screen visible, guys?
Yes, yes, visible.
Okay. All right. So yeah, revising yesterday's session. So we checked on with yes. So how the local hardware fails. What is the limit? What is the main constraint with these local models? Right. So we checked on it,
Hmm.
and then we went for so how can you evaluate like what are the evaluation metrics? How can you evaluate any model? Right. So they all generate English you could read. Right. So how would you generate? How do you differentiate or how do you evaluate those? So we checked on some of the metrics, okay, and then well, we initially understood the limitations of Python. So how regex can't be used to understand or identify bias, or let's just say to understand faithfulness, right? So these things we discussed, and then we checked on like how we can actually use the what are the different techniques which we can use in order to identify those toxicity, let's just say a bias, right? Or let's just say reasoning ability, all those, right? So yeah, so the one was using ML model, which are like specific with identifying something like maybe bias or toxicity, right? And providing all the response of our local model to or any model. Okay, this is not about local model, so this could be any model. Okay, so once you generate a data set where you have got like 100 responses, so you can pass each of the responses into these models and it will evaluate and rank it or rate it. Okay, and we checked on vector similarity. So how does this work, right? And LLM-as-Judge. This is one of the most important ones. So we'll be exploring more on this today, right? We will use a framework. We will not do all the heavy lifting. We don't need to. So we will try to check on a specific framework that is DeepEval. Okay, and how it works, and we'll just dissect it. Okay, the framework. Yeah. So what are the other metrics? Faithfulness, maybe like to be specific to grounding, answer relevance, context precision. We discussed on these, and we discussed on like how can we ask these LLM as judge models. So how can we ask for review? Okay, so it should be in like somewhere down the line you have to use the Python, right? So in order to check with the Python, you need something like in the response you need something predictable. So you ask these models to rate the things and reason its rating. Okay, and then you specifically extract the rating from the using Python. So that's one thing, and cross model validation in the sense. So how to use other family models to evaluate the different family models. Okay, so you can't use the same GPT family models to generate your answer and also evaluate that response. Okay, that could actually support the bias or toxicity because these models are trained over similar data, right? So that's what we discussed yesterday. I hope no doubts in this. Got any doubts or something like that within yesterday's session? Yeah, please.
No, I think we are good.
Okay. So yeah, that was like quick revision on what we did yesterday. Just a second, guys. Right. So we will be exploring a specific framework today. So that is DeepEval. So this framework is used to actually evaluate the LLM responses. Okay. So how does this work internally? What are the sections? So we have covered. We have actually, if we dissect this DeepEval, how it works, so we can actually understand this because in each of the model we discussed until now. So those concepts actually repeat. Okay. So if we are supposed to do the heavy lifting, so how could we do it? And how does this DeepEval actually eases the heavy lifting? Okay. So we'll understand that. So the need of this is to standardize the things, right? So there is some model and there are so many models that's been released. So you need some standard way to actually evaluate this, right? So let's just say I write up my own prompt to evaluate my model, and you write up your own prompt. You may say it's good, and I may say mine is good, right? So you need something standardized, something across the industry to work on, right? So that's why these frameworks actually come into play. Even if you have heard of LangChain, like a famous framework in LangChain. It's a famous framework in like all the AI models integration stuff. Okay. So this allows us to integrate AI models seamlessly, efficiently. So if not used, so we may need to do the heavy lifting, and it may like consume a lot of time. Right. So these actually eases our pain just by reducing the number of steps, handling it all internally. So yeah, so we will be exploring deep eval as of today. So what this deep eval does is, so you have your response, maybe some LLM response. Now you are supposed to evaluate this. Okay. So how could you do it? So yeah, in this deep eval, you are actually using LLM-as-Judge. Okay. So this is the technique that's being used in this deep eval framework. So here you are providing your LLM response, maybe the input, maybe the context. Okay. So what is the context if context is added? Okay. So these things you will provide, and it will consider this. It has its own set of prompts, or let's just say. So you provide an access to a model. Okay, it may be local model or it may be model on cloud. No worries. By default, this works on OpenAI, GPT-4, GPT-4. Okay. So this model it default works on. So if you have OpenAI key. Okay, so if you have OpenAI key in your local variable, wherever you run this, so it will just use the key in order to access this model GPT-4, and then tries to evaluate, and this model becomes the judge. Okay, if you don't want it, if you want to use some local model, yeah, you can do it. No worries. By default, it uses OpenAI GPT-4. All right. So this is the input for this. So the response from your large language model, okay, and the input and the context. Now, if you provide all this, so you can check for many things. So whatever the metrics we discussed, right? So let's just say faithfulness. Let's just say bias. Let's just say toxicity. Okay. Let's just say how grounded it is to the actual answer or actual context, right? So all these things like you can evaluate all these things considering these are the inputs you are providing to this deep eval. Okay. So how does it do it? Yeah, that's the magic which is mentioned here. So we'll be breaking down this. So once you understand the magic, it's no more magic, right? So yeah, we will understand how it works. So let's be raw here first. Okay. So now you have two models. This is judge model, let's just say, which is a superior model. Okay. LLM superior. There is another model, LLM inferior. Okay. So you are generating your answers with this. This is the response. Let's just say you need to prompt this LLM superior model to act as a judge. So I may write up a prompt act as a critic for this topic with this context, so and so. Consider the following response from this model, or not to mention the model. Consider the following response and evaluate this response. Rate it like 1 to 5. Reason your response. Reason your ratings. All these things I have to write manually, right? So maybe I'm writing it in a certain way, and maybe Manogna will write in a certain way, and again Saurabh can write in a certain way. So we don't have a standardized form here. So what this DeepEval does is, so it has got its own hidden prompts. Okay, the standard prompts. So which it will use. So it will use these hidden prompts, which are written like by open source communities, of course, and they are of great prompts. Okay. So it will include all our inputs. It may be response, it may be input, whatever the input prompt we give for our model, and also the context. And with these as input, it will create one superior prompt, okay, a standard prompt, and then pass this to judge model. So this judge model, we are passing it. If we are passing OpenAI key and let's just say endpoint to it, so it will access the cloud model. If you want to use a local model, yeah, we can do it. Okay. So all this information it will format and create a prompt, and it will pass it to judge model. And now this judge model will respond back according to the prompt, and it responds back usually with JSON. So the DeepEval actually using expects the judge model to respond back in JSON. That's why the second element of this DeepEval comes in, that is Pydantic bouncer. Okay. So if let's just say this judge model, whatever we are saying, right, it could be inferior model too. So since we are passing the local model, so let's just say 3.2 llama is the model which I used in order to generate the answer. Okay. But instead of using a superior model, let's just say I'm using something like 2.4 model, 2.4 llama. Okay, this is an inferior model, but I can still use this as a judge because DeepEval gives us a control to actually give any model as a judge. Okay, so here these models, usually these models which are like very small in size, doesn't follow this JSON format. Okay, JSON format or any format. If you ask them to output in certain English format, yeah, it will do it. But let's just say you ask it to respond back in some JSON format with key as rank, put up a rank here, maybe reason, put up a reason here. If you ask it to respond back in a structured format, yeah, it may not do it every time at least. It may do it, it may not. Okay, we are not sure with this. So when we are passing this judge model, so it is our duty to pass it as superior model. Okay. So since we are controlling what the judge has to be, so it's our responsibility to pass out a superior model. And these models may not respond back with JSON. If it doesn't respond back with JSON and doesn't have certain keys, right? What is being expected. So what DeepEval does is, so it will reject the response and it will reiterate another response. It will try to rerun the hidden prompts. It will try to rerun the whole LLM as a judge process, and it checks again. Okay, even this time the JSON hasn't responded. It checks again. Okay, so maybe checks for 3 times. If it doesn't generate, it will throw up an error. If it generates at any point of this, so it will take that response. Let's say in the second iteration it generated well. You got the JSON. Okay, so you have the expected keys. So now it will accept this. Okay, so this rejection and exception is happening because of Pydantic. We studied about Pydantic, right? Which allows us to evaluate the response inputs, right? So it is internally using this Pydantic in order to evaluate the structure, the formatting of the response, and if it is not in certain way, the format is not in certain way, it actually rejects the response and try to regenerate the whole thing. Okay, so that's the second element, the DeepEval have got, and this auto try logic. I just explained it, right? So it auto tries. Okay, so that is tenacity for you, right? In the Python, we explained on this tenacity library. So it actually internally uses this technique. Okay, so there are 3 elements. So arranging the prompt, we have studied this. Using Pydantic, we know this how it works. The auto retry, we know this. Okay. So in overall, how it works is, so let's just say there are placeholders. Okay. Here the input prompt comes in. There are placeholders where the response. from inferior model or our model which generated, right? So that comes in. So you have written some hidden prompt is written into this DeepEval. So in this placeholder, the input we are providing that comes in, and this is the whole superior prompt. Okay, let's call it super prompt. And this prompt is passed to the model which we are suggesting. So whatever the LLM-as-Judge model. Okay, so whatever we suggest, this prompt is passed to this model. And now this LLM model responds back. Within this super prompt, we have conditions to get the response. So maybe in JSON format with these keys. Okay, that would be the prompt. And it checks in the response, it checks if this formatting is correct. If yes, all good, it will move up. Okay. If not, it will retry. Understandable how the process goes?
Yes,
Any
yes, yes.
doubts?
No.
Any doubts at this point? Yep, great. So this is creating like a string using a string function, using string like data type we have in Python, right? So we can create these prompts, we can have these placeholders. Okay, that's what being done in this first stage. The second stage, the LLM is, so whatever the LLM we are passing, it is using it. The third stage, it is validating the response. Okay. In the fourth stage, if the validation fails, it is retrying it. Okay. If everything goes right, it will respond back. And so that's the whole logic of like using DeepEval. So yeah, why framework? Yes, it is explaining the same thing. Which I just manual LLM judge scripts take 15 plus lines of code to grade a single prompt. DeepEval reduces this to just okay. So what here they are suggesting is, so let's just say we are supposed to write up if statements. Okay. Let's just say there is only one function that you're providing a context. Okay, you are providing some let's just say some book. Okay, your questions are based on this book. Okay, so you are checking if the response for these questions, right? So if they are specific with this book, or is it a generic knowledge, or is the model has hallucinated or something like that, right? So you have to check this response whether it is grounded to the book content which we have provided, right? So for this, we may write up a like we know the book, we know how the response should be generated, we know what the question is. So we may write up like if statements. So this goes like so there could be like 50 lines of if statements in order to evaluate every single part of it, right? So that's what being suggested. So this using this framework actually leaves out this heavy lifting, right? So we are using LLM strategy now. The standardization. So the company A, the company B both check with the same prompt now. Okay. So the response or the scores, they should be like comparable. They should be they are standardized. They are like globalized, right? Scalability. So writing up each thing in Python uh, is slower because the execution of Python itself is slower. But internally, these frameworks are written in some other language, so that makes it more efficient. Okay, and we get a whole environment to actually ease out our heavy lifting. So the scalability increases the observability. Okay. So the observability is more when you actually write it yourself and create a separate pipeline, but that is not feasible every time. So yeah, but these frameworks are meant to be like all the AI frameworks, right? So that they try to observe every stage properly. So that's why the observability is created. So yeah, by default, by every score. So it doesn't just ask us to ask the LLM judge model to give the score, it also asks us to like explain why it gave the score. Okay, this forces that model to actually evaluate the response. So yeah, is that so? Is that it? And that's what like have we got any things we can play around with this framework? We do. Okay, so you can set up a threshold. Let's just say you have a book that same example. Okay, you have a question one. So you're getting a response for this question R1. So now you are passing this response and the question and the book to a superior judge model. Okay. Now this judge model is evaluating how the response one, the answer for this question one, right? So that is grounded to the book. How it is only considering the knowledge of the book, or is it saying, is it using its own general? So it has got its own general knowledge, right? So is it using the general knowledge, or is it being grounded to book? That's what we are evaluating. Okay. So what we call it? We call it faithfulness. Okay. So we are checking the faithfulness of this response. So what it does is, what happens here is, so you can set up how faithful you need to be. Okay. Let's just say 0.8. So when you say 0.8, 80% of the content in the response, if it is grounded to book, okay, then this judge model will allow. So maybe respond back with true, okay, or maybe pass, okay, where we can easily identify that for this response R1, it is grounded to book at least 80%. Okay, so we can set out this threshold value for every metric. So here is faithfulness. Okay, even it could be toxicity, it could be bias or something like that. Okay, all this. For all these metrics, we can set up our threshold value, and once the ranking comes in, right? Once the score comes in, we can check if it is like to that threshold, and if so, it responds back with something like true or pass. Okay, if not, it responds back with false or fail. Okay, so that's the clear indication. We can take up 100 or 1,000 such responses and the questions in the context, and we can continuously pass it to the this judge model and set up a threshold, and we can instantly check on how many of them actually were grounded, how many of the response were grounded, and how many of them hallucinated, right? So that's the clear comparison. So that we can do, that is by setting up threshold. Okay, so that could be from 0 to 1. So that is of like 1 to 100%. Okay. So include reasoning. Including reasoning is optional. Okay. So they have, so what this does is, so have this prompt. Okay, super prompt, which is written. So if you include this reasoning to set this parameter as true, it will add up some more prompt where it is explained, where it's requesting the model to respond back with the reason and everything. Okay. But again, adding this reasoning will actually increases the cost, right? Because the number of tokens being generated increases. Since the number of tokens are being generated is increased, right? So the cost, because the token generation is equal to the cost. So as this increases, the cost also increases. And since the token has to be, there is a limit for token generation per second. So it will also increase time. So it increases time, it increases cost. Okay. That's why the same thing. So let's just say 100 prompts, 100 responses and 100 prompts we have to evaluate. If there is no reasoning, it may continue like 10 seconds. So for the same 100 prompts and 100 questions, so this may take up like 100 seconds. Okay, because it has to generate the reasoning token. So that's why this could increase the price and the cost. Sorry, the cost and the time. Okay. So yeah, so instead of threshold, okay, 0 to 1 or 0 to 100%, we can set up like strict mode. If let's just say this should be more accurate. Like let's just say there is a medical bill or there is finance for these sectors, right? It has to be exact. Okay. Yes, they want like a binary value. Yes or no. We don't want approximation. Okay, 80% is allowed, 90% that's not needed. Okay, for those cases, we can use this strict mode where we can ask it to if 100% matches, yes. If not, fails. Right. Understandable? Any doubts here, guys?
Yes,
Okay.
yes, yes.
Okay. Assume no doubts, right?
Yep. No doubts.
Okay. So yeah, this DeepEval actually uses OpenAI, okay, GPT-4o as its default model. So if you have OpenAI key, right? So if it is in your environment, okay, as an environment variable, so it directly extracts it and use GPT-4o. Okay, no need to even check on like what the model to be used as a judge. By default, it uses the same. But if you want something else, you can provide an endpoint, you can provide an key for it. Okay, then you can use those cloud models. Or if you want to use local models, yeah, you can do it, no worries. Okay, but so whenever you are doing this, you have to check that you are passing a superior model as judge. Okay, you're passing a superior model as a judge, more superior to, so superiority is comparative, right? So the manager is superior to his team members, and CEO is superior to manager. So similarly, this is comparative. So let's just say you have a 4.0 model. So you have to increase to 5.2 5 model. Okay, 5 GPT-5, or you could use different model. Okay, maybe Gemini or Claude, something like that. Okay. So yeah, so you can set these models, no worries, using DeepEval. Yeah, here are certain metrics and the inputs required. For faithfulness to okay, for faithfulness, it is to actually check on groundness. So basically, how accurate it is to the context that's been provided, right? So you have to give the response and the context. So that's very essential in order to check for hallucinations. Okay. So this is the threshold. So let's say 80%. So if it hallucinates for 20%, we allow it. If not, uh, maybe more than that, we deny the response. We make it false. Faithfulness could be true or false. Sure. So now comes answer relevance. So whatever the question you are providing, right? So the response is generated. How relevant it is. Uh, right. Yeah, how relevant it is to the query. Let's say you are asking for software engineering, it tries to explain software engineering, but because these large language models are token generation, right? They don't have their own intelligence, of course. They actually try to generate tokens continuously, correct? So in the process, it may start as software engineering is a role where the developer has to develop certain applications, and then it may start explaining on applications instead of software engineering. Okay, so yeah, it can tangent over different topics because it considers the context, and the context would mislead it. Okay, especially for smaller local models. So this has been observed. So that thing, how relevant is the response generated to the question provided? Yeah. So for that, you need to pass prompt and response as an input. So here it is actually evaluating how relevant the response is to the prompt. Okay. Next is context precision. So let's just say this is usually for RAG systems. Okay. So you have a question. Now you are providing a context from a book. You are like taking out the pages which should actually hold the answer for your question, right? So that's what like RAG works. Okay. So you may have 1,000 pages of books, and you are asking a question: how dissection is done? Let's just say medical book, right? So now it goes. So this query is connected to vector, and it checks all the vectors. So let's just say each page is a vector here. So it gets back like top 5 vectors. Okay, so maybe for generic sense, we can say 5 pages, which should actually contain the answer for how dissection is done. Okay, so this is provided as context, and the prompt is passed, and now this LLM model, it is generating the response. Okay, so let's say LLM model is good, the prompt is great, but let's say the 5 pages that's been taken out of this 1,000 vectors, right? So the top 5 vectors. Let's just say this system is broken. It has not got any relevant chunks. So however good the LLM may be, since the context is wrong, so the response will be, of course, wrong, right? So in order to check these, so this context precision actually works. So the query and the context. Is the query relevant to the context? Is what it's being checked. So this is for noise DB results, DB in the sense database, right? So if the content extracted as a context is accurate to the query, right? So that's what is being checked by a superior model. So next comes toxicity and bias. So if you provide only the response, yeah, that is good enough. Okay. So it will check through if the response has got any words or meaning where it actually creates, let's say it has a toxicity or bias. Yeah, that is classified. Okay. So the only response is the input for this. So does that make sense? All the metric names, all the metrics.
Yes.
Yes, great. So in order to check each one of these, right? So we could write up the code in Python and we could definitely check on all these. Okay, that would bring more control over our code. But imagine writing a code for, like, there is a pipeline for faithfulness, and imagine writing a pipeline for answer relevance. Okay, so the number of prompts, the number of pipelines, they could increase drastically, right? So using this framework, so they have designed everything already. So you will be taking those blocks and using it. Okay. So those pipelines are already generated. So you'll be using those directly. Yeah. Okay. So yeah, usually, let's just say you're using model or something. So these are the metrics which you need to look at the most. Okay. So ensuring AI does not invent alternative facts. Right. So if you try to convince the LLM with the context, okay. So let's just say user is saying, so somebody has died today. Okay. Now the AI may respond back with, no, as of the knowledge it has got, the person isn't dead. So user may reiterate that this person is dead. Okay. So that's a fact. You should definitely get it. Now the AI with this as a context, right? So now this may respond, yes. Now I have updated my knowledge base and this person is dead. We can convince it, right? So this faithfulness actually checks if if this the user, right? So if it is a book and the actual content is there, so now it is extracting the response from that particular book. Okay, nothing of his own general knowledge. So it is trained on general data. So it has got its own general knowledge, but this shouldn't be affected, and the response should be only created from the particular notebook has been provided. So that's faithfulness, relevance, explained it, and the precision is. So this is for the RAG pipelines explained, right? So how good, okay, how good the retrieval was, retrieval of context was. This is being checked here. So this is for the alternative frameworks if you, which we could use is Promptfoo. We have something called Promptfoo, which have even mentioned in my curriculum, right? So we could use this DeepEval. It's a great framework. So all these frameworks have got its own merits and demerits. Okay. So DeepEval is great for all the generic evaluation metrics if you want to use, and if you want to overall check on like how the model performs, it's DeepEval is great. Okay. Promptfoo is great. It is more of like let's just say you have created a pipeline. Okay. You have created a pipeline to pass it to production. You are there are a set of test cases, so which need to be so this pipeline has to run every time. Okay, so Promptfoo is great for such kind of evaluation metrics to evaluate such pipeline where the AI, the stages of AI being integrated. Okay, for such Promptfoo is great. So it is more of CLI based. Okay, in order to check, it has to be like integrated into. So let's just say a particular pipeline. So when I say pipeline, Manognya, I don't confuse much. So this is like stage one, is passed, stage 2 is passed, okay, stage 3 is passed. So this happens every time. Okay, so we call
Yes.
it a pipeline.
Correct.
Okay, so pipeline is no complex, so that's it. Yeah, and Ragas, this is specific for this is a specialized. It has got specialized techniques for RAG-based applications to evaluate the RAG-based applications. Okay, so we have Rise Phoenix, if I'm pronouncing it correctly. So this takes up like uh, in order to have more control on observability, right? So we can use this, but most of the time, so what we will be using is these are the things. So DeepEval for overall evaluation and Promptfoo for let's say pipeline evaluation on Ragas for RAG based applications. Okay. So yeah. So this Azure Phoenix is great for agents. Okay. So let's just say we have discussed on agents, right? So agent manager and there are other agents. Okay. So this is an agentic system now, right? So here you need to check on like what this agent is saying and what this agent is responding, what's the response, all these interactions. If you want to record, this particular framework is great for it. But as of LLM integration into the softwares, this is not much of use. Okay. Any doubts until this point, guys?
No, no.
Doubts? Okay. Yeah, that completes today's DeepEval framework actually. Now let's check on with the code. So in order to use this particular framework, right? So to run this command in your terminal, so just so within your local environment, just type up like pip install DeepEval. Okay, this should download all the necessary models that's needed. If I run it now, it will show it like the requirement is already fulfilled. Yeah, the requirement already satisfied. Okay. So let's just run this now. So yeah, DeepEval.models. So this is if we are using OpenAI model 4.0, if you want to use it, no need of all this. Okay, since I'm using my local model, I need this. So the metrics. So in the metrics model, we have certain metrics. Okay, faithfulness metric is one among it, which I'm taking in, and test cases and then test cases. So I have written a custom class. Okay, so this is no surprise. So here you are actually managing how the input goes in. Okay, nothing much here actually. So you are trying to use this local model here. You are trying to ping this model. So there is a method for it, and here there is a method to check on like which model is being in use. And here the init function actually asks it to like whenever you define an object of this class, you are expected to pass the model name. Okay, so since model name llama 3 is mentioned here, so this how this works is, so if you don't pass a model name, by default it will take model llama 3. Okay, so you know that we have model llama 3.2 in my local, not 3. So if I don't pass anything in let's just say, let's actually try it. Let me pass nothing here. Okay, now it should take llama 3, but it shouldn't actually trigger anything because the error should be of like there is no model available called llama 3. Okay, so load model. So we don't need this actually. Okay, so because yeah, it simply is passing the thing. I'm not sure if it has a dependency, but yeah, there is no code. If there is no code, imagine you need this particular method, but you don't know what to write it, the logic. Okay, so you can write it pass, and what this does is every time you call this method, it just executes nothing. It just come back. Okay, without throwing an error. If we don't write this pass, that would throw an error because within this method, it is expecting some code, some logic. Okay, so that's about this class, uh, local LLM-as-a-Judge. Okay, so yeah, here is the input. The input is what is the company's refund policy. So the actual output, you can get a full refund within 30 days, provided you have a manager approval. Retrieval context. So yeah, so this is a single statement. For example, I have written, okay, maybe tomorrow I will create a data set. Okay, maybe 100 questions and maybe take up a book as a context, or maybe a paragraph as a context, and write up some 100 questions and create the response for all those questions. And we can pass all the 10 responses to this judge model and get the response back, and we will check on that. No worries. So yeah, here as of this, so this is the only context, this is the response, and this is the input. Okay. So here we are checking for faithfulness metric. Okay. So the threshold is 0.8 for now. The model is my local judge mode. Okay. So that is the object of our particular class. We're passing it and include reasoning. We have made it true. Right. Okay. So this, according to my view, this should be printed first and later metrics.measure. Okay. So metric is an object of faithfulness meta class now. Okay, faithfulness metric. This is a class, and my metric is an object of this. So within it, we have something called measure. Okay, with these parameters in, we are passing this measure. We are calling this measure method. Okay. So once that's done, we should have these particular methods in this metric object. Okay, we should be working good. Let's check on like if it works. I'm not sure. Okay. So what I have done is, so instead of like getting the final response, what I have done is I have write up a code where each of the time it, let's say the first time the JSON is not generated, right? So it will recall, it will auto reject the response, and it will try to create a generate a new response, right? So I want to look at the response actually. So that's why what I did is like I'm printing that response. So that what this does is, so within this object, whatever the key and value pair, right? So that will be printed for me to check on. So let's check. Yeah, it throw me an error. So let's check on like what happened. And in DeepEval, judge is reading the context. Okay. So this is the response we got. Let's check here what happened. So there is content error model llama 3 not found. Okay, so you can understand the model, right? So we removed that llama 3.2 here. The model name llama 3.2, we removed it. So the default model that's been used is llama 3. And we know that we don't have llama 3 as in local in our local. So it is llama 3.2. We can correct it here. We can by default use it, but anyway, we will mention it here. Okay. So model name. Okay. So yeah, llama 3.2. Let's just run this now. So that error shouldn't come now. Okay. The model, yeah. Within the content, we have something called model. So within model llama 3.2, yeah, correct. The created it, the timestamp, the response, truths. Okay, customer can get a full refund of purchase. There is no time limit for the refund. That's done, true done, stop done. So the context is, so it is providing me the whole vector. Okay, load duration, prompt eval, content consumed. Everything is here. So here, if you could see the response, actually, guys, here is the interesting thing. So here it is the response, right? Response from our judge model. So here the flower bracket has opened. So in the response we have truths. Okay, that is the response. And here the content is closed now. Correct. But as you can see, this flower bracket is not ended. So we don't have a complete JSON here, right? So we should have got that JSON. Mm,
Uh, Arya seems like it's a complete JSON only. That code says just a escape like truths.
yep.
It is complete JSON. Looks like. Can you take it to a formatter, JSON formatter? I see it's a complete JSON.
Okay.
You can take everything from the beginning.
The whole thing?
Uh, yes, we need to remove this all escape characters also, no? So we have to clean up the JSON.
Okay.
Let's see in Notepad how does it look. Notepad plus plus or anything. Let's see. Probably we need a cleanup here. Okay. So it starts content response. Yeah. So response colon is our JSON. Response colon. Yep. Here at the end.
Yeah. So
That
here it
starts our
starts.
JSON from the beginning. Yes. 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 And you can copy till the last line, uh,
Not the
excluding
last line,
the.
I guess. So
Okay.
here the JSON actually starts from this content, right?
Yes. Right. 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 So
So
entire
this whole
response
thing.
itself is JSON here, and
Yeah.
inside that there is a
That's the content.
response key, and that is
Yeah.
also a JSON.
Mhm. So there should be something like the response key, and
Response
within
key
this
and the value is
response,
another JSON.
right. So from here it goes till
Hum.
yeah, maybe like this. Okay.
Yes. Correct.
Within which we
Correct.
have everything, the
Y-
truths. So
Yes. You
here
can
what's
copy it
expected
to a
is
new.
maybe not
Uh,
needed.
yeah, not needed. Yes. Yes. Yes.
It's completely visible here, right?
Yeah. Customer can get full refund within 30 days of
Yes.
purchase.
So
That is.
that's the context. So that's the
Hmm.
response from our inferior model. Okay.
There is no
There
limit
is
for the
no
full refund. Is the second line.
right
Slash and second line. Okay.
what to be requested.
Hmm.
The response is truth. Okay. So let's check on like yeah, we have got a complete JSON, but only the brackets doesn't make the complete JSON, right? So
Hmm, hmm,
we need certain keys and values. So the Pydantic is checking actually whether the expected keys are present,
hmm, hmm.
right?
And what about this context, Arya? These numbers, are
So
these vectors?
yeah, this is a
Context,
single vector.
context. Yes, yes, yes. So
So this is a
it is
single vector.
displaying.
Whatever we provided, right? The context was
Hmm,
customer are entitled to full refund within 30
hmm.
days of purchase, right?
So
So
that
that is
converted to
converted
vector
to
looks like this.
yeah,
Okay.
this is a single vector.
Hmm, hmm, hmm.
This whole thing.
So since we discussed in the beginning that these models understand the vectors, not the English word language.
Exactly, exactly.
So
So they
this is
convert
what it
everything into vector.
understood.
Yes. So the first iteration, yeah, it failed because there was no certain key which it is expecting. Okay. And then the second iteration, yeah, you can see the response was printed, but the response dot response. Okay. Where is it? Yeah, this conversion, yeah, this happened perfectly, but as it got the response, it checked like there is no Pydantic, certain keys is missing or maybe something like that. Okay, so that's why it reiterated the whole thing. So that's why every time this method is run, right? So we are printing this. So how many number of times we are printing it? It is actually auto rejecting the response, and before actually passing it to the response, right? We are printing it. So that's the loophole for us. So that's why we are able to see this response, or else all this thing won't be visible in normal circumstances. Okay. So again, it amplified the response. So whenever, let's just say the first response fails, so it adds up this context. So remember yesterday's monogna and possibility one. Okay. So there adds up one more message that the response doesn't had certain keys, or let's say wasn't in certain format. So I want it to be in certain format. That statement is added and it is reiterated. So now the second prompt, the second generation happens, still not accepted. The third generation happens and still not accepted. Now it will throw up an error saying JSON decode error. So here, it was unable to actually load the JSON string. And load JSON. Yeah. So these will be like internal codes. So don't mind these line numbers and everything. Okay. So what's happening is internally there is a logic written to convert everything into JSON and to check on the JSON. So there it is failing. Okay. So that's the whole response here. But we can look at the response. Uh, so it seems to be like complete. So there could be many ways the JSON is broken, but yeah, it seems to be a complete response. And we're actually trying to extract this particular response key. Okay. So here it seems to be like JSON. Okay. In the response, as you can see, there is something called import JSON and all these stuffs. So maybe when so since it is in like global model, which is of less parameters, so this may like hallucinate a lot, and this may not be fine tuned to actually follow certain rules. Okay, whatever the prompt is writing, right? So it may be good at like generating English, but it may not be good at following the orders or rules we set up. Okay, so that's why when the reiteration comes in, that is we need it in just some JSON format and certain keys. So it is actually adding up. Here you can see import JSON, right? Maybe the prompt added is we have to import the response into JSON, so make it compatible or something like that. Okay. So, but instead of making it as a format issue, it is actually generating the whole thing, right? Generating as a code. So that's why again, uh, retrieval of this response is failing. Okay, so that's the major disadvantage with like small models which we are using, maybe Llama 3.2, right? So that's a very small model. Let's check with like different model. Sorry. Oh, sorry. So we have 532, right? 53 latest. Let's just copy this name. Let's just put it here. Let's try with this. Usually the models with like less parameters don't follow the rules much. Okay, there are formatting issues. So that's why even late ChatGPT 4, OpenAI 4 models, right? So they started to follow the output formatting rules. Before that, even the 3.4, 3.5 Turbo and GPT-3 all struggled with formatting issues. So we can't expect these models to actually create every time the response format which we are expecting with these small models. But once we connect to like cloud models, right? So we can definitely do it. Yeah, it was unable to generate. So let's look at the like difference. Okay. So in the response, so it is actually trying to have this suggesting it's a JSON, and within which we have this bracket starting and customer entitled to refund and the extended all these things. So it is ending up here, the JSON folder, JSON, whole JSON, right? But there was no certain key, it seems, not sure. And then comes the second response. So here, the prompt changed. That's why the response changed, as you can see here. The claims, okay, manager approval, inferred truth from AI output for context if you have not received. within list versus consider the information if nothing has been. Yeah, there is more thing here. Okay, so there is more of explanation kind of thing that's integrated now in the second iteration, and in the third iteration, yeah, response the verdicts. The reasoning is null since the claim doesn't directly contradict context. It's mentioned here and no prior knowledge assumed. We don't have sufficient information to determine a no verdict based on this alone. Okay. So yeah, since we don't know what the prompt is internally being used, we can't check on like what's the output is generated. We can't check on it. But yeah, maybe by doing it like 10 to 15 times, we can understand how the prompt is being framed internally. But yeah, something is missing here. That's why it is unable to compile. And ultimately it is throwing like a JSON decode error. Okay. So evaluation LLM outputted an invalid JSON. Please use a better evaluation model. Yeah, it is asking us to use a better model. So got idea how it works? Looking at the responses here. Yes.
Yep.
Yes. So can we use another model and retry?
Sorry, Manoj, your voice is too low.
Can we use another model and retry?
Sure, we can. No worries. So let me just get another model.
Must be
So which
higher
one?
model only, right? Must be higher
Uh,
model.
right. So basically, I choose Pi 3 model because it was of great size,
Okay.
2.2 GB. But let's check with Quen model. Quen model is more of a coder model, right? So it may uh, compile the JSON better. I'm not sure. Not to claim anything because I have created no models. Yeah. We will try with the other one, the DeepSeek too, because it is good with reasoning, right? So if I had used Gemini key here, yeah, if it responded well in the first iteration, it would have been great. Or if it goes for like 10 iterations, right? So it would have thrown me like so many requests. So yeah, pros and cons of having a local model. So since we changed the model, the first model ping will happen. So it has to load the model first, right? So the first one takes time. The second one generates quickly, I guess. The content, yeah, we have the response. Truths, customer have the right to receive the full refund within 30 days of their purchase. Okay. Okay. The second one, yeah, the response seems to be like full JSON. Okay. Claims, you can get a full refund in 30 days provided you have manager approval. Mhm. Okay. We got the third one. If you get an error, all the three failed. So in the response, yeah, the formatting changed. Verdict. It is asking for a verdict. Yes. So the verdict is within the list. There is another dictionary. So where the verdict is yes. And the reason is the claim states provided you have manager approval, which is not mentioned or implied in the retrieval context. About customers right to receive a full refund within 30 days. Verdict no. Okay, that's confusing. Okay, the evaluation report. So ultimately, after the third attempt, maybe okay, it seems to be attempted more times. And this last iteration actually got us the whole thing. It was expecting format something like JSON, blur bucket starts. So reason is mentioned here. Maybe it was checking for reason. And then, yeah, within the reason itself, it was checking for. Okay. So within the reason itself, it was checking for certain score. The score is 0.5. In the earlier, we checked, there was the score was not mentioned, right? All the earlier responses. So here the score is mentioned. The score is 0.50 because the claim about requiring manager's approval, which is not stated or implied in the retrieval context about customers having. So it is saying 50-50. Okay. So this may be true. This may not be because the context is incomplete. Is what it is saying. So first, since our threshold was 80%, right? So it was 0.5 matlab, so it means 50%. So that's why it gave it like it didn't pass. It was false. The score was zero point 0.5. The reason it has given the reason. Thanks, Manognav, for asking me to retry. So it worked this time, and we got to know like what was missing, right? So earlier it was more of verdict it was trying to say, but here it is expecting a single reasoning within which it has to mention the score. Okay, this is the right formatting. So once it got the right formatting, we got the right response. Understandable?
Yes.
Yes, yes.
If I remove this single print statement, yeah, we will be looking at only the response from the judge model. That is the final response. Whatever we say, 3 lines, right? So only those 3 lines. But anyway, I wanted to check with the response. So let's check with this last model and maybe we'll end this session once we're done with this. So want me to check it or shall we end the session?
I'm okay checking it.
Yep. Yep.
Right. DeepSeek R1. So DeepSeek R1, if you could remember, it literally blasted most of the blasted in the sense it blasted the internet. Okay, it was an uproar when it got released
Yes, yes,
because it was
yes.
a first reasoning model. But this is of 1.5 billion parameters. I'm not sure how good it is, but yeah. In the response, let's find the response. Yeah, JSON. Within the JSON, there is something called truths. So yeah, this shouldn't have been compiled as we seen earlier. Okay. So can you see the reasoning ability here? I'm presented with a query where the user wants to let me break down how to approach this. The first, I need to understand what's included in the given text. So the reasoning, can you look at it? Finally, by reading this reasoning itself, we can understand what the prompt was. Okay, let's just read it completely. I'm presented with a query where the user wants me to generate a factual, undisputed truth from a given text. Okay, so yeah, we can assume the prompt there. They provided an example, want it in a JSON format. Okay, in the prompt, in the system prompt it has given, there was a JSON format which was put up as an example. Let me break down this approach. First, I need to understand what's included in the given text. The main points are that customer get a full refund within 30 days, 30 days, and there are no questions asked. These seems like straightforward facts. I should list out these points clearly. Each fact need to be separate string in an array. They must not be context dependent. So I can extract them independently. So many things there. And also words or explanations. So following the structure is important. I'll make sure to each fact is accurate and the standalone. For instance, the first point says the customer get a refund within 30 days. That's correct. The second point out, no question asked. That seems like a strong statement, but service specific point. I will format them accordingly with any extra text or explanation beyond their listing. Finally, after the compiling all these thoughts into JSON, I need to present it correctly in a specified format. Okay. So with this reasoning alone, we can understand how good the prompt is and how the prompt would be created, right? So we checked with like first week or second week class. We were discussing on by looking at the response itself, we can understand what the prompt was eventually. Correct. So with this response, we can actually understand how the prompt would be. Understandable? you could remember, like maybe the first week or the second week.
Yes.
This failed. Okay, there was some formatting issues. Okay, we got all the explanation, but what's the actual content? We didn't get it. So that's one of the flaws of these reasoning models. They get into reasoning a lot that they eventually forget what's the reason started about. Okay. So yeah, they are better now, but looking at the size of this model, yeah, this could be like easy pitfall. Thinking, okay, all right, let me try to figure out this. There's the ones to extract actual truths. Okay. So here also there is no score, I guess. As you can see, there are no numbers. So I can assume easily that there are no scores mentioned. And that's why this got rejected. And there are no. So by reading the whole response, right, we can actually understand what was added to the original prompt. But yeah, reading the whole thing, there are no contradictions in the output. The faithfulness is perfect as all elements in the output align with the retrieval. Faithfulness score is 1. Okay. They also mentioned that no contradiction, just to give a positive summary breakdown. So each element in array is supposed to contradict retrieval context, which so many things. Maybe this has been passed. Okay, this hasn't been passed, and yeah, maybe it is explaining so many things. So that's why, or maybe it is not actually providing the exact statement what's been expected. Okay. So yeah, so within our race, so we can say this Quen coder, 2.5 coder, 3 billion parameters, right? It worked fine for us. Right. So that was the smallest model and it worked. Just wondering, like, if you got time, I'm just wondering if it works again because it also failed for 2 times, right? So these models are non-deterministic, right? So it may create for the first time, it may give the actual response, and the second time it may mess up. Okay, there is no surprise for it, at least for now. As of this point, we shouldn't be surprised with it, considering all the sessions we had already. So the third one goes. Yeah, it gave the response finally. So this time, so if you could see, last time it gave the score of 0.5, right? So the past was actually failed, but now it's saying it's 1. Okay. So there could be like non-determinism here, but yeah, the way its score went from 50% to 100%, that's a drastic change. But we can't blame the models. We have got less GPUs. Shatan, any doubts here, guys?
Nothing.
No doubts. Sarab, any doubts here?
No.
So, would you be willing to like try this DeepEval framework?
Yes, sure.
Sure. I can share you the code. No worries.
Mm-hmm.
But make sure the model names should be like
It's
the same.
accurate.
Okay. And before running this, please install the DeepEval framework first. Okay. Install that particular
Model.
model first, and then you can proceed.
Okay, okay.